So today, right now, we are going to start this field of electrical engineering, that is control systems. Okay, this is the subject, and we have divided this subject into 5 units. These are the recommended books. Mhm. Okay, so in the first unit, we will get the basic idea of control system, including the mechanical, electrical, thermal systems. And then industrial devices like potentiometer, tachogenerators, the motors, and all of these. And then in the second unit, we will move on to the transfer function, and we are going to refer this book for this purpose. Okay, here you can see uh, the introduction, open and closed loop. Here it starts with transfer function, poles in 0D, Alembert, and where is block diagram reduction. This is also in the second unit. MIMO, signal flow graph, Mason gain. But where is response, steady state? Nyquist, no, okay. Okay, let's start with the introduction only. Okay, these are the Laplace transform formulas given here. There are 12 of them. The Laplace of derivative of a function is Fs minus F. Laplace of the derivative with the power and gives here, and this is the summation. We will look forward to this while solving the formulas. Okay, this is also the unit impulse, unit step, the Laplace transform of e to the power of minus at, all of these sine cos. Okay, introduction. The control system is very important for our engineers. The first significant control device was James Watt flyball governor. This was invented in 1767 to keep the speed of engine constant by regulating the supply of steam. Okay. In control system, the behavioral system is described by differential equations. Minovsky in 1922 showed that how to determine the stability from the differential equations describing system. The differential equations may be ordinary or the difference equations. Okay. The first one is open loop control system. You have the input, a controller, there's a processing unit, and then there's an output. And some examples are given here. For example, washing machine, you give the input, the DC motor gets started, and all the functions are there. It get processed, and then okay, this is the part of that. The clothes, which are the load here, get the torque, and they rotate and all. The processing happens, and then the output. Okay. Advantages: open loop control system. They are economical, require less maintenance, and we do not want, to calibrate it. It's not such a big problem. And the disadvantages is, because we don't to do the calibration, it may be inaccurate, not reliable, slow, and optimization. Closed loop. It's just an open loop system with an add-on, and that add-on is feedback. Okay, what happens is there is an input and feedback. The feedback is from the last stage. Here, both of these signals are compared. Then there is an error signal. It amplifies, goes to the controller, getting a processing unit, and then we have the control output depending upon the input. And there's this example: in a room, we need to regulate the temperature and humidity. So the temperature is regulated according to humidity. The ACs are provided with thermostat by measuring the actual room temperature and compared it with desired temperature. So let's say the room temperature is here. It's get compared to the desired one. If there's a difference, the controllers do the necessary, and compressor gets activated, and hence again the new temperature is the feedback of this unit. More reliable, faster optimization. This is called optimization. We can do optimization according to our need. We can set the desired temperature. Okay. Closed loop are expensive. Yeah, there's an extra component called feedback. Okay. Maintenance difficult and complicated installation. Do the comparison, the same disadvantages and advantages. Not reliable, easier, simple, complex, calibration, accurate, stable, less stable, optimization is needed. Elements or components. The whole system can be, divided into some parts: reference input element, then the comparator, control element, control system, and then output. Before the output, there's a feedback element. Okay. Uh, you can you have to check the direction. The feedback is always from the output to the comparator. There's a command. Command is like, yeah, it is the input. Reference input element, like just here, the desired temperature was, let's say, 10 or 20, 12. So that is a reference input. Error detected, the room's temperature was 15 and the desired was 12. So the 3 degree Celsius is the error. So it is detected by the error detector component. Control element. This is the element that actually changes the properties. Like for here we have controller and compressor. Okay, and control system. This is apart from this input and output. If you see this part, that is control system. What we are controlling by the feedback loop. Okay, we are controlling this part. These two, not the input, not the output. We are just controlling. Okay, we are actually controlling the output also. So apart from input, this will be the control system. Feedback element, this block. Um, every type of system has a different block. Now, studying of the transfer function. But wait a minute. What, which book is this one? This is by Ali Grami. Okay, okay, okay. Okay, it does have all the things. Okay, okay. Translation system, I was looking for that only. Chalo, everything is there. Oh, I just have to look for this. What is this then? Okay. Oh, here we are again. Back to the things I was looking for, the updated system, syllabus, sorry. Okay, we are on the topic transfer function. Okay, everything is clear. We have looked into the open and closed loop system. We are going to start. Let me just write it down. Transfer function. Okay, as the name suggests, uh, transfer just means the transfer of energy from the input to the output, and function is a, you can say it is a mathematical representation or relation between the output and the input. So, okay, transfer function is just the ratio. We'll see here it is given. Okay, come on, assistant, hide for this session. This is, you can say, is type of transfer function where the CS denotes the output, controlled output, and the RS is the input. Okay, but there's a difference. It's just not the ratio. The transfer function is defined as the ratio of Laplace transform. So the ratio is not something, the output of one input is the ratio of Laplace transform of the output divided by or upon to the Laplace transform of input with all initial conditions zero. Okay, we will look forward why we need the initial conditions zero. Let's read. Consider a linear system having input R and C is CT is the output. Input output relation can be described by the following nth order differential equation. That is this one. You can see the power decreases as a and dn derivative of ct plus a n minus 1 d n minus 1 dn minus 1 with the output till a1 derivative of output plus a0 ct is equals to bm. Here we have taken n and here we will take b m, and similarly the m will get reduced down to 0. Okay, take the Laplace transform of both the equations 1.1 side by side, so the derivative becomes s when we take the Laplace transform, and the integral becomes 1 upon s. So here the derivative will become s with the power of n. So a n s with the power of n plus a n minus 1 s with the power of n minus 1. So the window is closed now. We will not have any disturbances. Okay. So transfer function was the is the ratio of Laplace transform of output upon Laplace transform of input. And the input and output was demonstrated in type of differential equation, then reduced with the Laplace transform. Now the CT, the time domain will become frequency domain and it will be CS. So we have taken common, CS is common here, RS is common here. We can define the transfer function as GS is equals to CS upon RS. So this CS will be there, RS will become here, it will come here. So CS upon RS is equals to that the B term upon A term. So this is equals to CS upon RS is equals to the B term and the A term. So that was it. It is given the question number. In that equation, if the order of the denominator polynomial is greater than the order of the numerator polynomial, the denominator was the numerator was b m s to the power of m minus 1 m till p0 s. You can see bm sm plus bm minus 1 s minus 1 till b0 upon amsm till a0. So stopping, it's saying that if the denominator, the term, eighth polynomial is the denominator polynomial's order is greater than the order of the numerator polynomial, that transformation is said to be strictly proper. Okay, if the order of both the polynomials are same, the transformation is proper. The transformation is said to be improper if the order of the numerator polynomial is greater. So it's saying, for example, the order of the numerator is 2 and the denominator is also 2. So it is proper if the numerator is greater. So it's 3, the denominator is 2, so 3 is greater than 2, it's improper. And if the numerator is 2, the denominator is 3. So 2 is less than 3, so it is strictly proper. Okay. Next, let me just write it down. Strictly proper, proper, and improper. For myself, I will just write down n, that is numerator, order. So order is, for strictly proper, it should be less. So less than denominator d order. And for proper, it should be equal. And for improper, the numerator is greater. I think, yes. Numerator's order and order is greater than the order. Okay. Consider the block diagram of the open loop. Open loop, okay, there is no feedback. Where RS and CS are Laplace transform of input and output, okay. Then transfer function is CS upon RS, Laplace of CT upon RT. Okay. Sorry, Laplace of CT upon Laplace of RT. Now it is saying the procedure. Write the differential equation of the system. Take the Laplace transform of the system, and then make it out into a ratio. We have gotten the ratio, reduce it to the obtain in step 3 is the required transfer function. Yeah, so that is the transfer function. Characteristic equation of a transfer function. Okay, let's see. What are its characteristics and how can we represent it in an equation? The characteristic equation of a linear system can be obtained by equating the denominator polynomial of the transfer function to 0. So if you there's a question that find the characteristic equation of a given transfer function, then what you have to do is the denominator's polynomial of the function, you have to equate it with 0. Thus, the transfer function is just the denominator AMS, sorry, ANSN till A0 is equals to 0. What are poles and what are zeros? Characteristic equation. We have to denominator is equals to 0. Next is poles and zeros. poles and zeros. Consider the same equation 1.3. This one CS1RS. It was GS was here. So CS1RS was BMSN till B0 upon AMSN till A0. Okay. The numerator and denominator can be factored in M and N terms respectively. So we can say, for example, there is a polynomial. How can I? Okay, just create. Can I create? Okay, this is our board for right now. For example, uh, a square plus b square plus 2ab. It is a factor as a plus b and a plus b. Yeah. So it is saying similarly we can also reduce a m s to the power of m. I think it was n here. Okay, we are just taking variables till a 0. This will become a constant and this will be a variable. So for example, we can take a square minus there's a constant here, so we'll add 4a square minus 3a, this is a plus a0, let's say that is 2. So you can find the roots by this formula, the quadratic equation. Okay. Similarly, it can be reduced to like minus of minus 3 is 3 plus minus this whole bracket will become minus 3 square, so 9. 9 minus 4 times 4 is 16. So 16 into 2. 9 minus 32. So 9 minus 32 is a negative number, so the roots will be imaginary. On twice of a is 8. So the roots will be imaginary and hence you can find the zeros or roots. Similarly, it is saying, oh, okay, but we have to find, this was the roots now. What I want to say is, you can always reduce, not always, but you can reduce the equation to factors. So, so the numerator get reduced to s, sorry, k, that is in constant, s plus z1, s plus z2, a square, the last three terms will be a square plus bs plus c, and s plus p1, s plus p2, a square, capital BS plus capital C. You may think where is this common constant is. It is taken as a whole one constant, the whole constant here, है ना? Yeah, it is here. See, I was trying to say this. The common is taken in the numerator, and the A common taken in the denominator is together taken as a constant. The fraction is taken as a constant. K is equals to B M over N. Is known as the gain factor. Okay, this is an important thing. So first, let me write CS upon RS is equals to GS. Yes, it is. And the K is there. I have remembered it. Z1 S plus Z2, and there is a coefficient A square BS plus C. Similarly, S plus P1. Okay, S plus P1, S plus P2, and capital A square, capital B, capital C. The K is minus B M upon A. There is no minus for this. Sorry. K is Bm upon An, known as gain factor. So if there is a question and it asks as what is the gain factor, you have to just find out as with the complex frequency. Hmm. So what are poles? Huh. The poles of GS are those values of S for which makes GS tend to infinity. So GS tend to infinity. For example, in equation 116, where is example 116? This one? Yeah, it is this one. So in order to make GS to infinity, think about this fraction only. Whenever there is a numerator as 0, it becomes closely to 0 or 0. You can say if you reduce it to 0, so the answer will get reduced to 0. If you reduce the denominator to 0, this whole fraction will tend to infinity. So what we have to do is we have to solve this for 0. So we can we can see we can make this bracket 0, this bracket as a 0, and this bracket as a 0. For this bracket to be 0, s can be minus p1, so it will cancel out and 0, minus p2, it will cancel out and it becomes 0. And also this quadratic equation, you can solve this quadratic equation. So the same thing I just told in the whiteboard. Then these two brackets will be is pretty simple, minus p1 minus p2, and this will become minus b plus minus b square minus 4ac 1 2a. Similarly, the zeros is those values for which the values of s for which gs tend to 0. So we have to equalize this numerator to 0. So you can say s becomes minus z1, s becomes minus z2, and solve this correlation. So minus z1 minus z2 and another two values, pair of zeros. So there will be 1, 2, 3, 4. Because this is a quadratic equation, s will has two values. Here also s will have two values. So 1, 2, 3, 4, 1, 2, 3, 4. So four values for which gs becomes 0 and four values for which gs becomes infinity. Similarly, minus b plus minus root under b square minus 4 is equal to 2a. This will give you another two zeros. If either poles or zeros coincide, for example, there is a value of pole which is minus 4 and there is a value of s that is 0, it's also minus 4. So they are saying for if coincide, then such type of poles or zeros are called multiple poles, okay, or multiple zeros. Otherwise, the values which do not match or which not are same similar, it is called simple zeros, simple poles. Multiple poles are due to the repetitive factor in denominator, and multiple poles are due to the repetitive factor in numerator. Chalo. For example, consider this. They have given a very good, easy formula. Let me just write S values for which GS becomes 0. Okay. So there's this question: GS is equals to 50 s plus 3 upon s into s plus 2 s plus 4 whole square. So this 50, I think it's k, and this is one factor. This is three factors in the numerator, and this is a square. So this is s square plus 16 plus 8s. Okay. So we don't have to, open the brackets. We can simply tell, if you say, if you can write it as s plus 4 into s plus 4. So for zeros it is minus 3, and for poles it is 0, minus 2, minus 4, and minus 4. Let's see, 0, minus 2, minus 4, and minus 4. It is multiple poles because there is two values of minus 4 as, like, they are coming twice. So we can say it has multiple poles, and that is the pole of order 2. And simple 0 s equals to s3. Multiple zeros at minus 4, we can also say the pole of order 2 at s equals to minus 4 are of finite values. If we consider the entire S plane including infinity, then two cases arise. If the number of zeros is less than the number of poles, then the value of transfer function becomes 0 for S becomes infinity. Okay, let me just write it down. If zeros is less than poles, just like in this question, 0 is 1 and the number of poles is 4. Then if S is infinity, transfer function is 0. Okay. There are zeros at infinity, and the order of such zeros is p minus z. There are three zeros as infinity. Okay. Okay, it is saying that if there is less number of zeros than poles, if we just subtract it. So p minus z in the above question, for example, p minus z becomes 4 minus 1, so it will be 3. So three zeros are at infinity. Okay. Therefore, the function has a total of 4 poles and 4 zeros in the entire S-plane. Okay, there's always the same number of poles and zeros. And if you found only the value of 1 0, the other three zeros are at infinity. And I think vice versa will happen. If the poles is less, then it will be at infinity only. Okay, if the number of poles are less than the number of zero, p is less than z, then the value of transfer function becomes infinity. For s becomes infinity. Okay, this changes. If s becomes infinity, transfer function also becomes infinity. Hence, we can say there are poles at infinity, and the order of the poles will be z minus p. Okay. Therefore, in addition to finite poles and finite zeros, if we consider poles and zeros at infinity, there is a rational function. The total number of zeros will always be equal to the poles. Pole is represented by x, and 0 is by 0. So we can see there's a 0 here, there's two poles here, one pole here, and one pole here. We'll study impulse response. Okay, let's see. From the above equation, not the above, this one, I think. No, not this one. Then, okay, this one. Suppose the system is subjected to a unit impulse, then the output will be Cs equals to Gs. Okay, unit impulse. The value of Rs is 1, so Cs is Gs because the Laplace of the unit impulse is becomes in unity becomes 1. So Gt is equals to Ct. Therefore, inverse Laplace of Gs is called impulse response. ओके जीएस था देन हमने उसका इनवर्स लैप्लेस ले लिया तो उसी को कहते हैं इम्पल्स रिस्पॉन्स इम्पल्स लैप्लेस इनवर्स लैप्लेस ऑफ जीएस इज कॉल्ड इम्पल्स